In this video, we're going to do a brief review of how to compose two functions or multiple functions. So the reason why we want to do this is because we want to take the derivative of more complex functions. Okay, to do that, we're going to want to use the chain rule, and the chain rule helps us to take derivatives of composite functions. So we want to know what composite functions are and how to decompose them in particular. A composition of two functions, f and g, is a new function h, where one function, so let's say f, takes the y value, takes the y value of the other function, so it's g in this case, as its input. Okay, so what I mean by that is where we see that when we talk about the notation. So h of x, we write it as like this. So it's f circle g, and this little circle you read as composed with. Okay, so f composed with g, and then because g is the one that's closer to x, that means that it goes first, i.e. it acts on x first. Okay, so this is going to be f of g of x. Okay, so you see we're going to take g of x first, the y value that we get from that, then we're going to take f of that y value. Okay, so that y value is going to be like our new x value. Okay, as a picture, you can sort of think, okay, so here's the domain of g. Okay, maybe I have x in there. So what's going to happen is that g is going to take x to g of x. Okay, and then f is going to take that point to f of g of x. Okay, and this lives in some other set here. Okay, so g and then f. Okay, but h just takes x all the way to here. Okay, so h is equal to f of g of x. Okay, so it's almost like you're skipping this middle part, but in fact you're doing it as well. So that's the idea behind a composition of functions. So let's just do an example. So consider the functions f of x is 3x minus 4, and g of x is the square root of 2x plus 3. Okay, so we want to determine each of the following compositions. So g composed with f of the number 1. Okay, so this is g of f of 1. So we want to compute f of 1. So maybe I'll do that underneath. Okay, so that's where we plug in the number 1 into f. So we get negative 1. Okay, so that's our new input to g. Okay, so that negative 1 is f of negative 1. So now in g, we want to simply put in negative 1. So it's going to be square root of 1, which is 1. Okay, so we would say that g composed with f of the number 1 is also the number 1. Okay, now what if we do this for general x? Okay, so g of f of x, so this is g composed with f of x. So it's going to be g of the function f of x. So instead of writing f of x, I'm going to write what the function is. So then we're going to plug that. This is our new input. Okay, so this is our new x. So wherever we see an x in g, we're going to put in f of x. Okay, so here's the x in g. I'm going to instead put in all of this. So it's going to be square root of 2 times 3x minus 4 plus 3. So if I simplify that, it's 6x minus 8 plus 3, so 6x minus 5. Okay, so that's g of f of x. Now, what happens if we do it in the other order? Will it be the same? So our new input, so we're going to have f of square root of 2x plus 3. Okay, so just like before, wherever we see an x in f, we're going to instead put in g of x. Okay, so this is going to be 3 times the square root of 2x plus 3 minus 4. Okay, so we can see that these are very different functions. Okay, they even have different domains. Okay, so they're not even defined for the same x values. For instance, f of g of x is defined when x is 0, but g of f of x is not. Okay, so this one is f composed with g of x. So my note here is that f of g of x does not equal g of f of x in general. Okay, or you could say f composed with g does not equal g composed with f. Okay, so those two functions are not the same. Now, what we are actually going to be interested in for using the chain rule is how to decompose a function. So instead of composing it, we want to break it down into its pieces. So we want to recognize that it's a composition of simpler functions. Okay, so I want to do a few examples where we decompose. So here's our first one. So it's 2x cubed plus 9, or plus 5, sorry, all to the power 9. So I've written it as f of g of x. Okay, so that means that f, we have an outer function and an inner function. Okay, so what we want to do is try to see if that exists in g. So what we want to think about is, so when I have an equation for f, wherever I see an x, I want to sub in g of x. Okay, so here, if my function f was, say, x to the 9, then I could put this whole function in for x, and I would get this f of g of x. So you could have my outer function is x to the 9, and my inner function as 2x cubed plus 5. So the inner part, oops. Okay, but there's other ways you could do this. So maybe I have my outside function is like x plus 5 to the 9. And then my inner function maybe is just 2x cubed. Okay, that would work as well. This one, the first one we did, is better for the chain rule. So it's just sort of the easiest function I can think of on the outside, and then a complicated, the sort of inner thing. I insert one thing. But there's lots of different ways you could do this. So let's try another one. So here I see that this 2x to the 5 minus 3 is inside some other function. Okay, so maybe I want that to be my g of x, my inner function. Okay, what would that mean my outer function is? Well, it would have to be the square root of x plus 7 on the outside. So that everywhere I see an x, okay, I put in my g of x. Again, are there alternatives? Yes, there are. But this is the best one, probably, for the chain rule. But you could have f of x is square root of x minus 3 plus 7. And then g of x could just be the 2x to the 5. Okay, there's lots of different ways to do this. Well, we're just practicing. Okay, now I have sine of 3x squared minus 2. So look for the inside function. It's going to be inside some other function. Okay, that's going to be the easiest way to figure this out. So I probably want my g of x to be 3x squared minus 2, and that means that my f of x is just going to be sine of x. So that when I replace this x with this, I get my composition function. Okay, slightly harder one. Here it's hard to tell what the inside function is. Okay, maybe I'm just going to rewrite it for you a bit. So this is 2 to the x squared, minus 1, over 3 times x squared minus 1. So it looks like I could be inserting x squared minus 1. So let's use that as our inner function. Now notice that it appears twice. So I could use my inner function, g of x, as x squared minus 1, and then I would have an outer function, 2 to the power x over 3x. So everywhere where I've highlighted, that's where I want my x's to be, because that's where I want to insert x squared minus 1. Okay, so you always want to be thinking there's an inner function and an outer function. Okay, inner function, outer function. Okay, so this is the outer and the inner. And it's normally easier to find the inner function first because the outer function is going to look a bit different, but the inner one you can usually see directly as it is. Okay, so that's just some practice with trying to decompose a complicated function into a composition of simpler functions.